Hi, in this video I'm going to be going through the intermediate maths paper from November 2022. I'll try and get it all into one video rather than splitting it up. So, skip past the first bit there. Our first question here is a rotational symmetry. It's rotational symmetry of order 2, which means it needs to look the same when it's upside down. You'll need tracing paper for this question. But if you put your tracing paper overlapping on here, put your pen in the middle, okay, trace the shapes, turn your paper halfway round and colour it in. You should end up colouring these squares here, okay, so that's what was in the top right is now in the bottom left. And then just be careful with this L shape because it does spin around, but if you've got some tracing paper, that's fairly easy. That's got rotational symmetry of order 2. Next question then is just about number facts. So the first one there is all prime numbers are odd numbers. Now that's almost true. Most prime numbers are odd numbers. The obvious exception is that the number 2 is even and it's a prime number. So if you just put in there the number 2 and mention that it's even and a prime number, you should get the marks for that one. And then very similar then underneath, all cube numbers are odd numbers. Well, some of them are and some of them are not. So there's a few examples you could pick here. 8 is an even cube number. That's 2 cubed. Okay, just say that that's an even cube number. You could even say that 4 cubed, which is 64, is an even cube number. So Duffrig is incorrect. On to the next page then. We are looking for a multiple of 5.5, so that's something in the 5.5 times table. Well, 5.5 and 5.5 is 11, so you're looking for something in the 11 times table possibly. So that'll be 33, okay, that's 6 lots of 5.5. And then a factor of 37, a factor of 111 is any number that goes into 111. You might have to do a little bit of mucking around on this one, and for 1 mark, maybe it's not worth it if you run out of time, but the number that goes into 111 is 37, and that goes in 3 times. If you just kind of write out the times table for each number and see which one of them gets to 111, it won't take you many. If you don't get there in sort of 3 times tables, it's probably not that answer. Okay, then we're on to some isometric drawing linked to volume. So first of all, we've got to find some potential dimensions for a cuboid that's got volume of 12 centimeters cubed. So volume is when you times the length, the width and the height together. So you've got a few options here actually. I mean, the most simple option would be 12 times 1 times 1, which would be a very, very long, thin cuboid. You can go with 6, 2, 1. That's 3 numbers that multiply to make 12. You've got 4, 3 and 1 as the dimensions, or even 3, 2 and 2. So any of those 4 combinations in any order will get you those first couple of marks. But then you have to draw it on the isometric paper. So I'm going to go with the 3 by 2 by 2 because it's the smallest one. So I think I'll be able to fit it onto the isometric paper. Now be careful with isometric paper. You have verticals, you have diagonals, you don't have any horizontal. So be careful how you join your spots up here. So the best way to do it is to start with a vertical line. So if we go 1, 2, 3, there's my 3 centimetre edge. Now I need a 2 centimetre for my other 2 dimensions. So follow the dots diagonally. If we have 2 that way and we have 2 that way, all I've got to do now is complete the rest of the cuboid. So we are 3 tall there, 3 tall there, 2 there, 2 there, and then we'll put a little roof on it. So that would be a 3 by 2 by 2 in isometric. You can spin it round, draw it different ways round, but you should always be following the dots either vertically or diagonally, but never horizontally. And then we're on to our next question, if the board will let me. So we've got to work out with some money now then, how many notes each person has got here. So they've only got 10s and 5s. Andrew's got 6 notes, and that's £55. So the only way you can do that is to go 10, 10, 10, and then 10, 10, 5. Okay, because you have to use 6 notes. If you have any more 5ers, it's too many notes. And Grace has got 5 notes, and she's got £35. So you got to just be a little bit careful you don't have too many notes. And the correct way of getting £35 with 5 notes is to go 10 and 10, which is 20, and then make up the missing 15 with fivers. Okay, so the total number of £10 notes would be 7, and the total number of £5 notes would be 4. Okay, there isn't another way of doing that one. You'd think there's some different combinations, but actually, because of the rules of the question, there is actually only one correct answer there. And then we've got a tiny bit of algebra here for question 6. So the first one is solving an equation. Golden rule for solving an equation is you've always got to work backwards and do the opposite. So the first thing we're going to do is add 3 to the 60. So that gives us 63. And now that's good news because our next step is to divide by 7, and 63 does divide by 7. 63 divided by 7 is 9. So P must be 9. Okay, work backwards, do the opposite. And then we've got down at the bottom for part B some simplifying. Be careful, don't mix this up with solving. All you're doing here is tidying up and making it look a bit nicer. So we've got 6 A's and we have to take away 2 A's. So that leaves us with 4A. Now don't go rushing and putting a plus sign in yet. We've got minus 7B and then we're taking away another 8B. So if you're on minus 7 to start with and you take away 8 more, that leaves you on minus 15B. It gets colder if it was a thermometer, starting cold and getting even colder. Next question's quite a nice one because you get a few marks just for listing combinations of different meals. So you've got a starter, a main course and a dessert. And really the trick to this one is just to work in a sort of a systematic way, to follow a pattern rather than jumping all over the place. So you're looking for 11 more combinations here, okay, as well as the one they've already got. There's 12 in total. So the best way to do this is to kind of fix your letters. So if I just keep melon the same, and then we can keep the chicken the same there, and we can go for whatever that was, I can't actually remember what it was, yogurt. Okay, so we got melon, chicken, and then fruit or yogurt. Then keep the melon the same, but change the chicken to ham. And then you can go fruit, or you can go melon, ham, yogurt. And then we've got one more sort of pair using melon. So you've got melon, pizza, fruit, or keeping again melon, pizza, and just change the last letter there to yogurt. And then all you've got to do then is change the starter to soup and repeat everything you've already done. Okay, because we haven't changed the starter column yet. So you've got S, 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 S. Okay, so we've got 2 with chicken, we've got 2 with ham, and we've got 2 with pizza, and then it goes fruit, yogurt, fruit, yogurt, fruit, and yogurt. So 12 combinations altogether, 11 that you have to find. Okay, number 8. This is a reverse averages question. So we've got 5 numbers in a list, and it can sometimes help if you actually draw the 5, even though they're blank cards, just to get your head around what's going on. So the mean of those cards is 7, meaning that when you add them all up and you divide by 5, you get the answer 7. Now, because it's reverse averages, and normally you would divide for a mean, we will actually times. And so 7 times 5 is 35. That tells me that these cards, these 5 cards, add up to 35. Right, then we add an extra card. So now we've got 6 cards. So 1, 2, 3, 4, 5, 6. And this time when you add them up and divide by how many, and how many this time is 6, the answer is 8.5. So this is a slightly trickier calculation to do, but it's just 6 times 8.5 to get the total. So if we go 85 times 6, and I'll put my decimal point back in afterwards, 6 5s are 30, 6 8s are 48, and 3 is 51, and if I put my decimal point back in at the end, 51.0. So the 6 cards must add up to 51. Whoops. So when it was 5 it added up to 35, when it's 6 it adds up to 51, the total is increased by 16, so the extra card must have a 16 on it, because that's the only way the totals will work. Number 9 then, ratio. Now be careful with ratio. A lot of people will just dive into it and see the 1 to 8 and assume that they're going to be dividing by 9. That's not always the case, and it's not the case on this question. So we've got 1 part to 8 parts, and again, drawing boxes, it helps you to see it, it helps you to get your head around what's actually happening. I do recommend for ratio you draw out your boxes. So it's not all of the money that's £16.80, it's the larger share, and the larger share is this side of the ratio, and that's 8 parts, not 9 parts. So our calculation to start is to split £16.80 into 8 equal parts, and that's bus stop division. So £16.80 divided by 8, so 8 into 1 doesn't go, 8 into 16 goes twice with no remainder, 8 into 8 goes once, and 8 into 0 doesn't go. So each part in this question is worth £2.10. Okay, to get your +2 OCW, your workings need to be neat and organised and in order, not all over the place. And when you've worked something out, just say what it is. So don't just put £2.10, write that one part or each part is £2.10. Right, what is the total amount of money shared? So you've got a few ways of doing this now. Now we know that this side of the ratio has also got £2.10. You could add £2.10 onto £16.80, or you could do £2.10 times 9, because there are 9 parts altogether. But the total amount of money, however you do it, is going to be £18.90. Probably quicker just to add on the extra part, the extra £2.10 onto the £16.80 we already had. Okay, number 10 is an estimation question. And when we estimate, we are rounding to make a calculation easier. And because we're trying to make it easy, we're going to round basically as much as we can, which is one significant figure as a rule. Which means I'm chopping each of these numbers after their first digit and then rounding appropriately. So 20.4 rounds to 20. 59.1 rounds up to 60. And 407 rounds down to 400. You should really have just one number at a time and then just lots of zeros, but the zeros are not going to be a problem for us. So 20 times 60 is 2 times 6 with 2 zeros stuck on the end, so 1,200. We're dividing by 400. As long as we do to the same to the top and the bottom, we can cancel some zeros out, so I can take 2 from each. That leaves me with 12 divided by 4, and 12 divided by 4 is 3. It's supposed to be easy, and if it's not easy, you've probably done your rounding wrong, or maybe you're not even rounding at all. But that word estimate is telling you to round the numbers before you start. Okay, number 11 is nth term, and it's quite a nice one because all you've got to do is sub in values of n. You're not finding the formula, you've been given it. So when it says we're finding the 10th term, that's telling us to use that n is 10. So that's 3 times 10, take away 13, which leaves you with 17. Okay, and the 4th term, which is going to go negative, and that's why they've done the 10th one first. So n is 4, so that's 3 times 4, which is 12, take away 13, leaves you with minus 1. All it is substituting into a formula. It's not even really sequences because we're only doing one number at a time. That's more like just basic algebra there. Okay? But if you did it over and over again, you would generate a sequence. Okay, number 12 is all about bias on dice and whether they're fair or not. Okay, so we've got a 6-sided dice, and the probability of scoring any number on a 6-sided dice is 1 over 6. And that's the same for all 6 numbers on the dice. They're all equally likely to come up. But if you look at Samira's table, she's rolled it 300 times and her results are nowhere near the same, really. We've got 65 ones, 42s, only 10 4s and 110 6s. So I'm already a bit suspicious that this dice is actually biased, okay? But part A is all about relative frequency, and relative frequency is like probability, but for an experiment. So we're told that the probability of throwing a 5 is 23 out of 300. That's because she got 23 5s and she threw the dice 300 times. So we've got to do the same thing but for 2. So she got 40 2s out of 300 throws altogether. Okay? If you take the zeros off, divide by 10, that's 4 over 30. And if you half the top and half the bottom, 2 over 15. And you have to do that because the question does say simplest form. Now, part B, do the results in the table suggest that Samira's dice is biased? Now, you can't really come to any conclusion other than yes here. Definitely biased. The non-mathematical version would be that she's got lots more 6s than 4s, for instance. That's too much of a change. There's too much variation. If you want to be a bit more mathematical, if she's throwing the dice 300 times and 1/6 of 300 is 50, that's 300 divided by 6. If the dice was fair, I would expect it to be around 50 of every number. Not exactly, because life doesn't work like that, but close to 50 for each number, and we're nowhere near. So your explanation there is just something along the lines of she's got too many 6s, not enough 4s. The dice does appear to be biased. And then the dice is thrown 2,400 times. Use Samira's results. So not using 1 over 6, because remember this dice is not fair. We've got to use the values from the table above. So this is now a combination of everything we've done so far on this question. First of all, we need the relative frequency of getting a 6. So that's 110 out of 300, like we did in part A. And the question is asking us if she did it 2,400 times. Now, in this question, 2,400 is not just some random number the examiner has come up with. Our denominator at the minute is 300. The denominator they want us to work with is 2,400. These numbers are linked, they are connected, and the connection is timesing by 8. And if you times by 8 on the bottom, you need to times by 8 on the top, which gives you 880. Now be a little bit careful, do not leave your answer in fraction form. It didn't ask for a probability or a relative frequency, it asked for a number of times. So really, you should be writing separately 880 as your answer. Okay, the mark scheme does say if you leave it in a fraction, you will only get 1 mark out of 2. Okay, flying through now. So question 13 is an area and perimeter problem. So the total area of the two shapes is 184. Find the perimeter of the square. It doesn't sound like you've got a lot to go on, but remember a property of a square is that all 4 sides are the same length. Right, now we have some numbers for the rectangle. We've got a 9 and we've got a 15. So 9 times 15 is 135 and our units are centimetres squared. The total amount of area for both shapes is 184. If we to 184 take away 135, that leaves us with 49 centimetres squared for the square. Okay. Now remember what I said a minute ago. A property of a square is that all 4 sides are the same length. We know that when you multiply 2 of those sides together, you get 49. There is only one number that will do that for you, and that is if the sides are 7 centimetres each, because 7 sevens are 49. But you're still not done yet, because the question asks us to find the perimeter of the square. So perimeter is when you go around the outside adding up all your edges. So we've got 7 add 7, add 7, add 7, or 4 times 7, but adding is more appropriate for perimeter, which is 28 centimetres for 5 marks. Okay, so that's quite a nice question. Number 14 is a Venn diagram. And we know from reading the question that our Venn diagram has to add up to 200. And I would always recommend on a Venn diagram question, you do check at the end that it adds up to what it's supposed to. Generally speaking, I would like to start in the middle of the Venn diagram, because the middle, this section here, that's going to affect the numbers on the left and the right because they're going to be included. So do we know about the number of people who have black hair and glasses? Yes, we do. It's 20. Okay. We're also told that 105 people don't have black hair and do not wear glasses. So that's easy to fill in as well because they go on the outside there. We're told that 70 people have black hair, but remember that includes the 20 people that we've already put in the middle. So that means we've got just 50 that only have black hair and don't wear glasses. And to fill in that last box now for people who have glasses but not black hair, this is where we've got to make our Venn diagram add up to 200. If you add up the numbers we've already got, it adds up to 175. So we're missing 25. Okay, but always start in the middle for a Venn diagram and you should be okay. One of these people is chosen at random. What is the probability? We're looking for a fraction that this person wears glasses. Now a lot of people will rush into this and go for 25 out of 200, but remember those people in the middle wear glasses as well. So if all I'm interested in is whether they wear glasses or not, my answer is 45 out of 200. It doesn't ask me to simplify that, so I'm not going to bother. It would be 9 over 40, but if you try to simplify and make a mistake, you can be penalised. Okay, so unless it says to, maybe it's not worth the hassle. Right, number 15 is not a particularly nice question because it's constructions with a compass and you really do have to know your construction rules here. So we've got a 60-degree angle and a 45-degree angle to draw. So a 60-degree angle, that's probably the nicest one to do. A 60-degree angle is basically an equilateral triangle. So what I'm going to do, I'm not even going to measure this, so I'll just bring it out to maybe there-ish so it doesn't look like I've gone halfway, because I'm not measuring this. It doesn't matter as long as you do the same to both sides. And I'm just going to go up and over and stop somewhere up there. Okay. And what we're trying to do here is make a sort of a tent, if you like. Just put that back and bring that back round. Now then, swap your compass to the other side and put it on the mark you just drew there. Make sure it's the same width, mine did change, but put it on the side you've just drawn and then go up and over again and you sort of make like a little tent there with some bits sticking out the top. All you've got to do now is join up from there to there and there's your 60-degree angle. Okay. Now I'll draw it a bit longer than I need to at the minute because if I was working in pencil I could rub this out, I would do a construction line, but I'll draw it nice and thick so you can see it. So there's the 60. The 45 is actually a little bit trickier. So what we need to do here is draw a 90-degree angle first and then chop that 90-degree angle in half. Let me get rid of that. Let me get back on there. So to draw a 45-degree angle, a 90-degree angle, you have to go sort of in the middle of a line and do what I would call the fishy, okay, which is where you draw an arc from both sides and those arcs overlap. So what I'm going to do, I think my compass is going to stretch all the way out there, so this is going to be a bit awkward for me on the board. So I'm going to put a little mark there, and then I'm going to swap the compass to the other side, and I'm going to do a little mark there, okay? And the reason I'm doing that is because now C is dead in the middle of those two blue marks, okay? And I'm just going to put, and I'll put it dotted, I'm just going to extend that line out a little bit as well there. Okay, because you can't draw a 90-degree anywhere except in the middle. Okay, let's move that down a touch. It's a bit awkward on the board. Oops, there we go. Right, now then, this is where you have to draw your what I call the fish now. Okay, it's your perpendicular bisector to give its proper name. So I'll change the colour to green. So open your compass more than halfway past the middle. Okay, if we go to about there-ish, and you need to do a sort of quite a full arc like that. And then without changing the width of your compass, swap sides and do the same thing from over here. Okay, the important thing is you don't change your compass. And you've got sort of the two overlapping arcs, which I think look like a fish. That's your 90-degree angle. So if we come up here from C, one sec, let's move that over, there we go. So there's my 90-degree angle. All I've got to do now is chop that in half. And again, this is really testing all of your constructions. It's not a nice question, this one. So to chop an angle in half, we've got to start in the middle there. I'll go for red this time. Okay, we move that just in there so it's not in the way of the other one. So you just put a little marker on one side and then come around here and do the same thing there. Okay, move your compass up and you've just got to draw like a little arc there, and then we swap sides and we go down here to the one we just drew. I'm trying to colour code this so you can see which ones they match up with, and where they overlap, that's your 45 degree. So that's a hell of a lot of work there, and that's if you know what you're doing with your constructions. So there's my finished triangle. All you've got left to do now is to shorten off the longer lines. Leave your arcs on. Your arcs are your workings on that question. So you could take off your construction lines, but make sure you leave your actual compass work on the page. Okay, then we're back to something a bit more sort of ordinary and normal, and most people like this question. So this is prime factor form, where you've got to do your tree. Okay, split it up using your prime numbers. Remember, prime numbers 2, 3, 5, 7, 11, 13. They go on, but you're unlikely to need bigger than that in one of these questions. I like to use 2, 3 and 5 as much as possible. 2's not going to work. 3, I don't know if it's going to work or not. I'm sure that 5 will, because the number ends in a 5. So I'm going to divide by 5 first. Okay, it's a non-calculated paper. I don't know what that is divided by 5. So I'll just do some long division over here to make sure I don't do something silly. So 5 into 1 doesn't go. 5 into 15 is 3. 5 into 7 goes once, remainder 2. And 5 into 25 goes 5 times. So 315 goes on there. Okay. Circle your prime number dead end to make sure you don't split it again. And then we are splitting the 315. Again, we can't use 2. 3 does work. 5 definitely will work. Okay. Remember, if it ends in a 5, it divides by 5. So if we go 5 again, because we know for certain that's going to work. So 315 divided by 5, so 5 into 3 doesn't go. 5 into 31 goes 6 times, remainder 1, and 5 into 15 goes 3 times. So now we're down to 63, and the times table's again a bit more manageable now. Okay. Now when I see 63, I immediately think of 7 nines, and 7 is a prime number, so that's a dead end. 9's not a prime number, so be careful. You'd be surprised how many people circle 9 to be a dead end. But 9 is 3 times 3, and there you've got your dead ends. All you've got to do now is put this all together now with powers, because index form means it has to have powers in it to get all the marks. So we've got 2 3's, so that's 3 squared. We've got 2 5's, so that's 5 squared. And we've got a 7, and remember it's product, so that's times in, not adding. Is there anything else on this page? No. So on to the next page, which is where we find some indices. So simplifying indices. So when you're multiplying, it's multiply the numbers and add the powers. So 2 times 3 is 6. We've got p cubed and p to the power 4. Add them together, you've got 7. So p to the power 7. We've got q to the power of 1 and q to the power of 7. Add them together, that's q to the power of 8. Then we've got to do some expanding and simplifying. Okay, so expanding brackets times the outside by the insides. So we've got 7a times a, 7a squared, 7a times 5, 35a. Now be careful, because that minus number, that minus 2 is going to do work for all of these. So we've got minus 2 times 3a squared. So that's minus 6a squared. We've got minus 2 times 6a, so that becomes minus 12a. And we've got minus 2 times minus 7, be careful, that becomes plus 14. If we put our a squareds together then, we've got 7a squared there, take away 6a squared, that leaves us with 1a squared. You can put the 1 in if you want to. Then if we do our a's, so we've got 35a there, and we're taking away 12a, so that gives us 23a, and numbers is just the 14 all on its own, so plus 14, and that's 4 marks, okay? So even if you just did the expanding, you're going to get a couple of marks here without doing the tidying up, okay? Nearly done. Question 18, so this is all about gradient and intercept. Gradient is how steep the line is, and to do that, you need to draw some little triangles underneath your graph. So find a sort of a nice little corner where it meets the graph perfectly. I would say that's a nice corner there. Then find yourself another nice little corner where it meets the graph, so I'll go for that one. Draw a right angle triangle underneath, and to find the gradient we are doing height divided by width. So we're going from 2 to 6, so our triangle is 4 tall, and we're going from 1 to 2, so that's 1 wide, so our gradient is 4 divided by 1. 4 divided by 1 is 4, so our gradient is 4. Okay. Our intercept, which we'll need for the next bit, where we cross the y-axis, is minus 2, so the equation of this line is 4x minus 2. Okay, gradient first, intercept second, 4x minus 2. The x part is always the gradient. Okay, and then part B, this is getting, a little bit tricky now, I suppose. Check that these lines are parallel to each other. Parallel meaning they have the same gradient, they will never meet. So this first line's got a gradient of 3. Okay, there's our gradient 3. We've got to see if the other equation has got a gradient of 3. And it'd be really tricky because they've given it to us in a horrible format. Remember, we need to have y equals mx plus c with a single y on its own. So there's some rearranging to do here. The first thing we need to do is to pick up that minus 6x and put it back to the other side where it will become plus 6x. So that looks like that. Or you could write 23 plus 6x. But since we're going for mx plus c, it makes sense to have that first. But we need a single y on its own, so now we've got to divide everything by 2. So 6 divided by 2, that's easy enough. That's going to give us 3x. And 23 divided by 2, well, I mean, it's 11.5, but actually it doesn't matter. We've already answered the question, because we have a gradient of 3 on this line, we have a gradient of 3 on this line, so they are parallel because they both have a gradient of 3. That's quite a tough question. These ones you're just counting up letters to get dimensions of formulae, and you're going term by term, so your options are 1, 2, 3 or none. Remember, you can't have a mix. Okay, so we've got 2 letters there, 2 letters there. On this last term, now this is a bit, I don't like these, because normally in maths you wouldn't be allowed to cancel out a B on the top with a C on the bottom because they're different letters. But in the topic dimensions, it doesn't matter what letter it is, you can cancel out if you've got letters top and bottom. So actually, like that B and that C can cancel out, and that does leave us with 2 letters. So 2 is area 2D. Okay. The next one, we've got 3 letters, A, B, C. 2 letters, and we've got 2 on the end here because b squared counts as 2. So that's a mix, that is. You can't have a mix, so that's none. That's impossible. For the next one, we've got a squared b, that's 3 altogether, AB, and we've got b squared a, that's another 3. 3 and 3, that's volume, that's okay, you can do that, 3D. The next one's even easier. We've got 1 letter there, 1 letter there, and 1 letter there, and that's length. Okay, because length is 1-dimensional. And then the bottom one there, we've got a squared, which is 2 letters, ABC, which is 3 letters. That's a mix again, so that's none. Okay, so area none, volume, length none. And then we've got 2 questions left. Question 20 is dividing in standard form, so I'm going to rewrite it as a division because it's easier to see what's going on like that. So the rule for division is that you divide your big numbers, your front numbers, and you take away your powers. Now, unfortunately, these are not a very nice way round because we have to do 3 divided by 6, not 6 divided by 3, which would be easier. So 3 divided by 6, there's a few ways you can do this. If you think of £3 shared between 6 people, okay, or another way of saying it is that 3 over 6 is the same as a half. Either way, you get 0.5. If it was money, it'd be 50p. Okay, so 0.5, take off that 0 because I don't need it. And then take away your powers. And again, they're being a little sneaky because you've got a minus. So we're taking away a minus. 4 take away minus 3 actually gives you 7 because you end up adding. Okay? If you leave that as your answer though, you're going to get no marks because the rules of standard form is that this needs to be between 1 and 10. So I need to make this one bigger, so that goes up to 5. And when that number goes up, the power comes down to keep it all in balance. So 5 times 10 to the power of 6. That's quite a tough question. Adding in standard form, well, the only thing you've really got to remember here is to take it out of standard form. So we've got a 4, 7, 8, and it's 4 jumps. So 1, 2, 3, 4. So that's 2 zeros on the end. And we've got a 1.5 times 10 to the power of 2. So that's 1.5, then 1, 2. And just make sure they're lined up properly. Sort of pushed off to the right. Make sure your columns are lined up. Then you add these together. So 0, 5, 9, 7, and 4. And once you've done your adding, you've got to put it back into standard form. So that's 1, 2, 3, 4, stop there. 4.795 times 10 to the power of 4. Okay, definitely the safest way of doing adding and subtracting is to take them out of standard form. And then our last question, which you wouldn't expect to see on a paper one, Pythagoras and trigonometry, but it's just multiple choice, you don't have to do any workings out. So really you've just got to decide here, is this adding Pythagoras or taking away Pythagoras? We have the longest side, so it's definitely taking away Pythagoras, so let's get rid of those, doesn't it? We always have to square root at the end, so it can't be that one, so we're left with one of those two. And remember, in Pythagoras you do your squaring separately, so it's 25 squared to take away 10 squared, so this one is right and that one is wrong. We would never put it in brackets and square it all in one go. And then for the bottom one then, we've got to pick between, they're all sine, so that doesn't really help, but they're sine because this is the opposite and this is the hypotenuse. If you actually write out your sine formula, so sine theta equals O over H. So sine 40 equals y over 25. There's your answer. Okay, so treat it like a normal trigonometry question, but you don't actually have to do any workings out. And that is a bit of a speed run through the November 2022 paper one. I hope that's been helpful.